Well, welcome back. Let's talk about this business process diagram. We've just been working on the show business example. And remember that this diagram consists of a bubble, something we call terminator, which is the extremity of the system. We're going to come to that in a second, and various objects. This diagram shows what's done to support an event. It doesn't show how we're going to implement it. Let's go back over here just for a moment and take a look. You remember here we had a customer asks for a product. So we get the request from the customer, we check our inventory, if it is available, we show the product and the price, we give that to the customer. If the customer wishes to purchase, we get the payment. We keep track of the payment, we keep track of the outlet in which the customer purchased the product, we keep track of the salesperson who served the customer, and we see if the customer already exists in our database, in our records. And if they don't, we get some customer information and we keep track of that new customer. Now this has to do with what is required, but there's a complete absence of how we're going to implement it. How we implement it doesn't particularly matter at this point. What really matters is that we understand the requirement, and then, whether it be yourself or whether it be someone else, we can think of the best technologies that are suitable to your organization to be able to apply to this. So let's go back over here and take a look at the components that make up the business process diagram. First of all, there are objects such as customer and payment and product and so forth. And each object has to have a definition. We have to say at some point in time, what is a payment? What is a customer? You'll recall that in our example, we decided a customer was somebody who bought lime green loafer size 13 from us, or they bought product from us. But we also said that a customer could be someone who asks about a product but doesn't buy anything. So we have customers who buy, and we also keep track of customers who don't buy as much as possible as well. Every object, such as customer and payment and so on, has to have data attributes. That is, data items that are attributed to the object. For example, for payment, we want to be able to know the date of the payment. We want to be able to know the amount of the payment, the taxes involved, and so forth. And we have business rules. Now, where do the business rules come from? Well, you'll recall, if we go back over here, that for this diagram, this process that supports this event, the serve customer process that supports the event a customer asks for a product, we have a business rules table. And all of the questions in the business rules table are in the context of the serve customer process. Each of these rules that show up in these cells get attributed to the anchor object, and the rules are written up under each one. So here we have a whole bunch of rules that would be written up under customer, and here we have some rules that get written up under product as well. We also have to have pointers to other objects in data, or what some people would call foreign key. For example, if we know about a payment number 54 for $127, we might want to find out who's the customer who made that payment. So we have to be able to have a pointer inside payment that points to the customer, or joins that record, if you like, to the customer who made that payment. The same thing with the product. If we have a specific pair of lime green loafers size 13, maybe we want to know who the lucky customer was that bought that product, because it's probably the only customer who's bought it. So we'll have a pointer or a foreign key inside the product, inside the product record, that points to the customer who loved lime green loafers. So those are the kind of things that are part of the object. We also have, we have Arnold, of course, what we call the terminator. A terminator, some people refer to these as actors in the world of UML and so forth, but a terminator is an external source for information, or a destination of information. So we can get information from a customer, such as a payment. We get payment information. We can also send stuff to a customer, such as the product that they purchased and so forth. Now, bear in mind that a process does not necessarily have a terminator. And sometimes the information that we get is strictly from inside the objects that participate in that process. And the information that we keep track of or send somewhere is also internal to the process itself. So some of these terminators can also be objects. For example, if we want to keep track of the customer who made the payment, we have to have a customer object. So the customer object is the data about the customer, whereas a terminator is the real customer in this particular case. Okay. So a data flow between a terminator and a business process, any of these data flows here between the terminator and the process must be a communication dialogue eventually, but not now. Right now, we don't really want to stipulate or want to think about what might be or how might we implement this. That comes a little bit later. Right now, we're just focusing on what is it, rather than how are we going to get it or how are we going to send it to the customer. The terminators, by the way, for any process, you recall I said there might not be a terminator, or there might be one terminator in the process, but you can also have more than one terminator in a process as well. The narrative itself is fairly straightforward. You'll recall that I said that for every diagram there has to be a narrative, of course, and it has to be in plain business language. You don't want to have it resembling some kind of a language other than a business language. Okay? You don't want it resembling some kind of code, for example. Okay? So let's keep it plain and simple and in terms that the client can clearly understand and relate to. And you recall that for every data flow coming in, and every data, and here's another one here, and every data flow going out from the process. Here we have reducing the inventory. Here we have a payment being recorded. Everything going out, we just have bullet points. We have a point for each one of these, and for each one of those data flows coming in or data flows going out, we have a task statement. Very, very straightforward and not complicated at all. Now, the style you use doesn't really matter. What matters is that for every data flow coming in and for every data flow going out, that there has to be a stated task, and it has to be clearly stated as well. So here you have a sample, and I think you have this separately as well, sort of a cheat sheet, if you like, of a simple business process, the one we walked through that we created a little bit earlier for the shoe store. We have the narrative as a sample. We have a definition of customer. We have some business rules. We have some data attributes. And, of course, there's going to be a business rules table. Every process that you work on has to have all of these ingredients. Now, the object definition, data attributes, business rules, and so on, that applies to every object, not just the example we're going to show here. So, what's an object again? Well, an object is always a noun. It's a person, place, or thing. An object has to have substance. Now, what I call substance in this case is that it has to have two or more data attributes. If it only has one data attribute, then it's just a data attribute. It's not an object. An object is always a noun, but data attributes are always are nouns as well. So if there's only one of them, how can we tell the difference? Remember that an object is a collection of information about some specific thing. And as such, being a collection, we must have two or more data attributes. Now, on the technical side, in terms of database implementation, that's different. But for business analysis, there must be two or more. We must also have business rules. Where did the business rules come from? They come from the business rules table that we talked about.